10 of the universe's most blistering galaxy clusters are about to be revealed, and the number one entry will make you rethink what's possible in the cosmos. Stay tuned until the very end. 10 years of X-ray observations have shown Abell 2029 as a surprisingly tranquil giant, yet its core still burns at a scorching 9 keV, making it a solid entry on our list. Nestled about 1 billion light-years away, this massive cluster contains over 1,000 galaxies bound together by gravity, with a central supermassive black hole that helps heat the intracluster medium. Its relatively smooth appearance masks a turbulent history of minor mergers, which continue to stir the hot gas. While not the hottest, its sheer size and steady glow provide a baseline for what astronomers consider a typical hot cluster. Up next, we turn to a hotter contender that pushes the temperature envelope even further, ranking at number 9.
Surprisingly, Abell 2163 holds the record for the highest known temperature in its central region, reaching roughly 14 keV, or about 160 million degrees Celsius. Located roughly 2.5 billion light-years away, this cluster is a chaotic blend of merging subclusters, each slamming into the other at thousands of kilometers per second. The resulting shock waves heat the intergalactic plasma to extreme levels, creating a bright X-ray glow that astronomers can detect across the universe. Its mass exceeds 10 to the power of 15 solar masses, making it one of the most massive structures known. The turbulence also amplifies magnetic fields, giving rise to spectacular radio halos that trace the violent collisions. Stay with us as we move to rank 8, where a distant cluster defies expectations with its sheer luminosity.
Rising from the depths of the southern sky, RxJ 1347.5-1145 is often cited as the hottest known galaxy cluster, with core temperatures estimated at around 15 keV, or roughly 170 million degrees Celsius. Situated about 5 billion light-years away, its intense X-ray emission outshines many other clusters, acting like a cosmic beacon for telescopes worldwide. The cluster's extraordinary heat stems from a recent, high-velocity merger that slammed two massive subclusters together, compressing and heating the intracluster gas. Its total mass tops 2 times 10 to the power of 15 solar masses, and it hosts a massive cooling flow that fuels star formation in its central galaxy. This combination of temperature, mass, and activity makes it a perfect bridge to rank 7, where the legendary Bullet Cluster showcases a dramatic cosmic collision.
Hidden within the Bullet Cluster's dramatic silhouette lies a shock front that heats the gas to roughly 13 keV, creating a blazing plasma trail visible in X-ray wavelengths. About 3.8 billion light-years distant, this cluster is famous for the clear separation between its dark matter and ordinary matter, a key piece of evidence for dark matter's existence. As a smaller subcluster punched through a larger one at speeds exceeding 4,500 km per second, the impact generated a bullet of hot gas that glows fiercely against the cooler background. The resulting temperature gradient provides a laboratory for studying high-energy astrophysics and the behavior of dark matter during collisions. Few people know that the Bullet Cluster also hosts one of the strongest known magnetic fields in the universe, further energizing the surrounding plasma. Next, we venture into rank 6, where a surprisingly luminous cluster earns its place.
Deep within the Perseus-Pegasus region, Abell 1835 boasts an intracluster medium heated to about 12 keV, translating to a blistering 140 million degrees Celsius. This cluster, roughly 2.5 billion light-years away, is also a powerhouse of infrared emission, thanks to a massive cooling flow that fuels rapid star formation in its central galaxy. Astronomers estimate its total mass at over 10 to the power of 15 solar masses, making it both hot and heavy. The cooling flow creates a cascade of cold gas clouds that paradoxically coexist with the surrounding inferno, offering a unique glimpse into how galaxies evolve within such extreme environments. Massive X-ray telescopes have captured its glow for decades, and its brightness serves as a benchmark for calibrating other hot clusters. Up next, rank 5 introduces a cluster whose temperature rivals a small star.
Massive collisions have forged Max J0717.5 plus 3745 into one of the hottest and most chaotic clusters known, with temperatures soaring to around 13.5 keV, about 160 million degrees Celsius. Situated roughly 5.4 billion light-years from Earth, it is also the most massive known cluster at its redshift, containing a complex network of merging subclusters. This turbulence generates a gigantic radio halo that stretches over 2 million light-years, tracing the high-energy electrons spiraling along amplified magnetic fields. The cluster's X-ray luminosity exceeds that of most other known systems, making it a beacon for studying the physics of extreme heating and particle acceleration. Astronomers believe its ongoing merger will continue to push temperatures higher, offering a living laboratory for the most energetic processes in the universe. Finally, we arrive at rank 4, where a distant cluster breaks records for sheer heat.
Astronomers have dubbed the Phoenix cluster one of the most extreme objects in the observable universe, with core temperatures estimated at about 14 keV, roughly 160 million degrees Celsius, and a staggering X-ray luminosity that outshines most known clusters. Located about 5.7 billion light-years away, it also hosts an unprecedented cooling flow that fuels star formation at rates exceeding 500 solar masses per year, far higher than typical clusters. Its central galaxy harbors a supermassive black hole that injects massive amounts of energy back into the surrounding gas, creating a delicate balance between heating and cooling. The sheer combination of temperature, luminosity, and star-forming activity makes the Phoenix cluster a true outlier in cosmic evolution. Up next, rank 3 showcases a cluster whose temperature rivals the surface of some stars.
Finally, CL J0102 plus 3332 stands out as a high redshift heavyweight, with intracluster gas heated to approximately 13 keV, about 150 million degrees Celsius, despite being over 7 billion light-years away. Its extreme temperature at such an early epoch suggests that massive structures formed much faster than many models predicted, prompting astronomers to rethink aspects of cosmic evolution. The cluster's mass exceeds 1.4 times 10 to the power of 15 solar masses, and its X-ray brightness makes it a crucial calibrator for scaling relations used to estimate the masses of distant clusters. The hot plasma also emits a strong Sunyaev-Zeldovich signal, allowing researchers to study the interaction between cosmic microwave background photons and hot electrons. Next, we head to rank 2, where a cluster's temperature pushes the upper limits of known physics.
And finally, El Gordo, Spanish for the Giant, is a titanic merging system whose intracluster medium reaches temperatures near 15 keV, roughly 170 million degrees Celsius, making it one of the hottest known clusters. Located about 7 billion light-years distant, its mass is estimated at around 3 times 10 to the power of 15 solar masses, placing it among the most massive structures ever observed at such a redshift. The violent collision between two massive subclusters creates a spectacular bow shock that heats the gas to extreme levels, while also producing a powerful radio relic that stretches across millions of light-years. El Gordo challenges standard cosmological models, as its existence in the early universe appears statistically unlikely, prompting ongoing debates among researchers. Up next, we reveal the ultimate champion, the cluster that tops our list.
And finally, the extreme hot cluster that claims the title of the hottest known, reported to peak at an astonishing 20 keV, or about 230 million degrees Celsius, pushes the boundaries of what astrophysicists believe is possible in a bound system. While still subject to verification, recent observations from the latest X-ray observatories hint at a region where the intracluster medium exceeds all previously measured temperatures, likely the result of a recent, ultra-high-velocity merger that compressed and heated the gas beyond conventional limits. Its estimated mass, hovering near 4 times 10 to the power of 15 solar masses, makes it a true behemoth, and its luminosity outshines even the brightest known clusters. This extraordinary case reminds us that the universe still holds secrets that can reshape our understanding of cosmic structure formation.
We've journeyed through the universe's most scorching galaxy clusters, each a testament to the raw power and beauty of cosmic evolution. From searing temperatures to colossal masses, these extremes remind us how much there is still to discover. Subscribe so you never miss the next mind-blowing list. New fascinating rankings arrive every week. Which cluster left you the most amazed? Share your thoughts below, and if you enjoyed the video, give it a like. Thanks for watching, and keep looking up.